on your skin or turn it brown. Okay? Paper, same thing. Okay? Sulfuric acid, right, is also considered a oxidizing agent. Okay? That is why we do not want you guys to add that to the iron 2 complex that we actually laid out. Because if you're willing to do this and it's already reacting here, then you're going to see the reaction over here because it's attacking, not the potassium permanganate. Okay, so you understand that. And on top of that, I just answered one of your questions. I did. Okay, I told you guys to take notes. Okay, so that's why we don't want you to do that. Okay, now. So you know the volume of the potassium permanganate was used to titrate this to reach the endpoint. You also need what else? We want to take the moles of potassium permanganate ion. What? It's molarity. Okay? And that, of course, is written on the bottle that they use labeled out. So make sure you guys write that number down as well. You know the concentration of the potassium permanganate. You know also the volume of this thing. Now remember, the units on the burette is what? What is it reading? The units. Milliliters. But molarity by definition is what though? Moles per liter. So make sure you guys convert either one. Liters to milliliters or milliliters to liter. Now, as long as they're the same, it doesn't matter. From that, you calculate what? Number of moles of potassium permanganate. Looking at the reaction though, here or here, the big one, I think is the moles of the permanganate ion though. Can anybody tell me how do we calculate that?
Mole ratio?
Huh?
Mole ratio of iron to permanganate ion?
The mole ratio of the iron to... Remember, the only information we calculate right now is the number of moles of potassium permanganate. That's all you know.
Oh.
So you know the number of moles of potassium permanganate. How do we calculate the number of moles of just the permanganate ion, which is here?
Well, permanganate ion is 1 mole per sodium, potassium permanganate.
Okay, so you have potassium permanganate, right? You take that and throw it into water, what happens to it? It dissociates 100%. Remember, it's not bonding. This is actually ionic. So, but they do dissociate 100%. You have what? K plus ion and the permanganate ion. So, what's the ratio going to be?
1 to 1.
1 to 1 to 1. That's what I wrote here. K plus that makes this, or this makes this and that, and dissociate. That's aqueous. Okay, good. So, if you know the moles of this, so say for example it's 5 moles, then how many moles of the permanganate ion? 5 moles. There you go. Now, you know this thing, right? So that can go here, that's fine. Now, how do you calculate therefore the moles of the, what is it actually? Is it iron plus 2? Yeah. So how do you calculate that?
Use mole ratio.
Use the mole ratio between what?
Between permanganate and iron. 1 to 5.
Which is what? What's the ratio going to be?
1 to 5.
Or 5 to 1, right? But the mole ratio is 5 to 1, so the conversion factor is 5 to 1. There we go. So 5 times 5 will be what?
25.
25. 5 times 5 is 25. If the answer was this. That's what it works out. Okay? So now you know the moles of the iron plus 2. Right? And now how do you calculate that for the mass of the iron? Because that's what you guys need. Huh?
Molar mass.
Molar mass. Okay. But what would be the atomic mass for iron plus 2?
50 something.
What would it be? Do we have one for iron plus 2? Atomic mass of iron plus 2. Well, what do we have here? You guys keep looking over here. It's the mass. We know the atomic mass of iron, right? The element form, right? Yes. Which is what? 55.847. Okay. That's fine. that's for what? Iron solid. But what about the molar mass for iron plus 2?
It's the same.
Why is it the same?
Because electrons didn't weigh much.
Well, that's true, right? So let's see here. This is what I started off with, right? Iron solid, and it's a metal. What does it do with electrons? Loses them. So I'm making plus 2, right? I lose 2 electrons. Therefore, what do I have here? Iron plus 2. Okay? So a millimoles of this, right? It's 1 to 1 to 1, but really, how many iron plus 2s are you actually using? 5. But how many of this you have to use? 5. This one is in a standard state, in a standard form. Therefore, this is 5 moles here. The ratio will be what? 5 to 5, which will be 1. 16 ounces. Now that you have that, yeah, then you use the molar mass, which is that number. That's what you do it. Very, very standard. How that works out. Okay? But like I said, you guys can do none of this stuff but without having to know this part first. You need the balance chemical reaction. Alright, good. Any questions about the calculation of all that stuff? Okay? Yeah.
Can you please explain the water again? I was lost. Like, how do you add water? I don't know how much water you can add.
This is part one of the steps that says in order to balance things out. Because the fact that I have 4 oxygens over here,
oh,
I have
4
nothing
water.
over here of oxygen present, you're allowed to put water molecules in there.
Okay.
Depending on how many water molecules how many oxygen shows up, that's how many you're supposed to
Yeah.
put for water.
Okay. Thank you.
Alright. Okay, any other questions about this? Remember the total amount that you get, remember, it has to include the molar mass of the iron 2 ammonium sulfate water complex, which is the hydrate. Don't forget to include the 6 moles of water. That's part of the total. Again, one of the questions says to calculate the percent of iron in a certain sample of stuff. You need the full thing. Don't forget that. Alright, no more questions about this? Alright, so now, some of the hazards, and I already mentioned some to you guys already. Okay, one is the potassium permanganate. It's the real dark purple looking solvent. Right? That's your oxidizing agent. Okay? Try not to get it on your skin, on your clothing, okay, or on your papers, okay, because they will oxidize the stuff, okay. If you get it on your hands, you can simply just wash it off, right, but it'll stain afterwards, okay. So, also don't ingest this stuff because it will do very bad stuff inside your body, okay. It's going to start tearing stuff apart. So let's not do that. Sulfuric acid. It is 1 molar concentration. Okay? So this is also considered a corrosive. And so it can eat through stuff, like paper and whatnot. Clothing, this stuff here, you get it on your clothing, and as the water actually starts to evaporate, the concentration does what? It increases. It increases. It's not the other way around where it decreases because you dilute it. As the water evaporates on your clothing, the concentration goes up. Therefore, even though if you wash them and whatnot, the next time around when you look at your clothes, it's going to have a hole. And you will find it. Okay, so be very careful not to get this stuff on your clothing with sulfuric acid. Okay? It's also, like I said, an oxidizing agent as well. So that's why we don't want you guys reacting with this stuff, putting this stuff inside here until you're ready to titrate every single one. Okay, so before you do the runs. The other thing is this. It says in the manual you're supposed to, at some point when you're titrating, okay, the solution is going to turn like a yellow-green color. Okay. Well, what they decided to do, he decided to switch it around. And he said, at that point, you're supposed to come over here, okay, and this is phosphoric acid. It is 6 molar. Now, it's not a strong acid, but it's still constant enough that, yeah, it's still corrosive and it still eat through stuff, okay? Now, this guy, however, in the manual, it tells you it's supposed to be a different percentage or whatnot, a certain amount. But the problem with this is the one that says use in the manual, it's very, very concentrated, so it's very, very thick. It's kind of like syrup. So if you try to dispense that material out, it wouldn't even come out. So what they did was, he made up a different solution of this stuff. Okay, so he typed this out about 7.4 milliliters. He's already set this for that amount. So the same one that was in here, just take the knob here. You're going to pull all the way up until it stops.